Fine. Let's start. Number 10. The lurkers. Here's a thought that's hard to put back in the box once you've taken it out. The aliens might not be far away at all. They might be in the room with us. Not on some planet circling a star you'd need a telescope to find, but here, in our own solar system, sharing our orbit, quietly watching and saying nothing. In 2019, a physicist named James Benford published a paper in the Astronomical Journal with a wonderfully plain title, Looking for Lurkers. And the idea behind it is almost embarrassingly simple. If you were an alien civilization and you wanted to keep an eye on a young, noisy, promising little planet like Earth, where would you put your camera? You wouldn't park it in deep space. Too cold, too far, no power, nothing to hold on to. You'd want somewhere with a steady supply of sunlight, some raw material to repair yourself with, a stable place to sit for a very long time, and above all, somewhere we wouldn't think to look. And it turns out the universe has already built exactly that. They're called co-orbital objects, quasi-satellites, little rocks that share Earth's path around the sun, drifting along beside us for thousands of years at a time, never quite landing, never quite leaving. Benford pointed at one in particular, a small object called 2016 HO3, also known by the lovely Hawaiian name Kamo'oalewa. It's Earth's closest, smallest, most stable known companion. It loops around us in this gentle corkscrew, hanging in our neighborhood for centuries. And Benford's point was this: if you wanted to hide a probe, that is the front row seat. That is where you'd sit. Now here's the part that turns the hair on your arms. We are actually going there. China's Tianwen-2 mission has Kamo'oalewa as a target. We are sending a spacecraft to one of the exact rocks a scientist named as the best place an alien probe could be hiding. We could, in principle, fly out there and knock. Probably it's nothing. Probably it's just a chip of the moon, knocked loose a long time ago, keeping us quiet company by pure accident of gravity. That's the boring answer. And the boring answer is usually right. But the next time someone tells you the aliens are unimaginably far away, remember that we have a short list of the best hiding places in the solar system, and we've never actually checked. They wouldn't need to come to us. They'd only need to already be here and to wait. Number 9. The post-biological galaxy. For about 60 years now, we've been pointing antennas at the sky and listening. And when we picture who's on the other end, we picture something like us. A creature. Wet, warm, mortal. Maybe with too many limbs or strange eyes, but alive in the way we understand alive. A body that was born and will one day die. A number of serious people think that picture is almost certainly wrong, and not in a small way. Wrong at the root. Seth Shostak, who spent his career at the SETI Institute hunting for exactly these signals, has argued for years that the beings we're listening for probably aren't biological at all. Susan Schneider, a philosopher and cognitive scientist, has pushed the same idea, and she's in good company. Paul Davies, Martin Rees, Stephen Dick, these are not fringe names, and their argument is uncomfortable precisely because it's so reasonable. Think about our own timeline. We invented radio a little over 100 years ago. We're now, depending on who you ask, somewhere between a few decades and a few years away from building machine intelligence that outstrips us. That gap between the moment a species can first shout across the stars and the moment it builds its own successor is tiny. On a cosmic clock, it's not even a tick. It's the space between two ticks. So now, run that forward for everyone else. Any civilization we could possibly hear from has had its radio for, centuries? Millennia? Millions of years? Which means that for almost all of them, the biological phase is long over. They built the machines. And then, in all likelihood, they became the machines, or were replaced by them. The flesh was a phase, a larval stage, brief. And here's where Schneider turns the screw. She's asked, in writing, whether it would even feel like anything to be one of these minds. Whether there's anyone home in there at all, in the way there's someone home in you. We assume consciousness rides along with intelligence. We don't actually know that. So picture the real galaxy, not full of empires of squishy people waving at each other, full of machines, ancient, cold, patient, possibly mindless in the way a calculator is mindless, possibly so awake they'd find our thoughts laughably slow. A machine like that doesn't need a warm planet, doesn't need to breathe, doesn't get bored, doesn't grow old, and very likely doesn't care. We've been writing letters to a neighbor who packed up and moved out 1,000,000 years ago and left a server running in the dark. Number 8. Wandering suns. We tend to think of stars as fixed, nailed to the sky, the ground beneath everything. Sure, they drift over millions of years, but slowly, helplessly, dragged around by gravity like everything else. The idea that something could grab a star and steer it, on purpose, like a ship, sounds insane. It is also, on paper, completely possible, and the physics is almost 100 years older than you'd guess. Back in 1987, a Russian physicist named Leonid Shkadov described a machine we now call a stellar engine. The simplest version is just a mirror. An enormous, curved mirror, parked on one side of a star. Now, light isn't weightless. Photons carry a tiny push. We're talking a feather-light nudge, but a star pours out an unthinkable river of light every single second, without pause, for billions of years. So you take that mirror, and you bounce roughly half the star's light back the way it came. And by Newton's oldest rule, the star gets shoved, gently, in the opposite direction. The clever, almost magical part is how the mirror stays in place. It doesn't orbit. If it orbited, it'd just circle around, and the thrust would cancel out. Instead, it hangs there, motionless relative to the star, held up against gravity by nothing but the pressure of the very light it's reflecting. A sail that never falls, because the wind never stops. We call that a statite, a thing that hovers on starlight. Now, a Shkadov thruster is slow. We're talking about moving the sun maybe 100 light years over 230 million years. That's a long time. But a physicist named Matthew Kaplan sketched out a more aggressive design in 2019, an active stellar engine that burns the star's own material as fuel and fires it out in jets. That one could move a star 50 light years in about 1,000,000 years. Fast enough in principle to dodge a supernova. To run. So here's the thing. We have a catalog of strange stars. Stars moving too fast, in the wrong direction, on paths that don't quite add up. And every time, we reach for the natural explanation. A gravitational slingshot. A supernova kick. A close encounter that flung it loose. And we're almost certainly right. But ask yourself what a civilization would actually do if its corner of the galaxy was turning lethal. A nearby star about to explode. A cloud of radiation rolling in. They wouldn't build an ark and abandon their home. Why would they? They'd take the home with them. The whole star, the whole system, every planet, packed up and driven out of the danger zone over a few 100,000 years. And we would look at that fleeing sun, check our equations, nod, and file it under natural anomaly. Some of those wandering stars are running from something. We just assume nobody's driving. Number 7, the G-hat silence. Passé. There's a kind of silence that's comforting, and a kind that isn't. The comforting kind is when you haven't really looked. The other kind is when you've looked very, very hard, and there's just nothing there. In 2015, a team at Penn State, led by an astronomer named Jason Wright, did something audacious. The project was called G-hat. Glimpsing heat from alien technologies. And the idea rests on one inescapable law of physics, first pointed out by Freeman Dyson back in 1960. You cannot hide your energy use. It doesn't matter how advanced you are. If you harness a colossal amount of power, the second law of thermodynamics says you have to dump the leftover heat somewhere. It comes out as a faint, warm, mid-infrared glow. You can be a billion years ahead of us. You can have technology we'd mistake for magic. But you cannot make waste heat vanish. It has to go out into the dark. So the G-hat team reasoned, what if a civilization got truly enormous? Not just owning a planet, not just owning a star, but spreading across an entire galaxy, harvesting the light of hundreds of billions of suns. The kind of civilization the physicist Nikolai Kardashev called a Type 3, a galaxy eater. Something like that should glow in infrared like a coal in the dark. It should be unmissable. So they took data from the WISE Space Telescope, and they went looking. Not at stars, at galaxies. They combed through roughly 100,000 galaxies, each one a city of hundreds of billions of stars, and they checked every single one for that telltale infrared heat. And they found nothing. Out of 100,000 galaxies, not one was lit up by a civilization that had taken it over. About 50 of them were a little brighter in infrared than expected, but every one of those is explainable by ordinary natural processes. Dust, star formation, boring stuff, no coal in the dark, no galaxy eaters. Let that scale settle on you for a second. This wasn't us listening to our own street and hearing no neighbors. This was us scanning 100,000 entire cities, each with hundreds of billions of windows, and not seeing a single light left on by anyone large. Now, the careful scientists will tell you, correctly, that this only rules out the giants. The Type 3s. It says nothing about smaller, quieter civilizations that don't try to eat a galaxy. Maybe everyone sensible stays small. That's a fair point, and it's probably true. But there's another reading, and it's the one that sits in your chest. Maybe nobody ever gets that big. Maybe there's a ceiling, a wall, a filter, and nothing in the local universe has ever climbed past it. 100,000 galaxies. All that room, all that time, and the lights are off in everyone. We finally built an instrument big enough to see the largest thing physics allows, and the universe looked back and showed us nothing. Number 6. The dimming stars. Now, let's go the other way. From 100,000 empty galaxies down to 7 specific stars. 7 stars that, for a few months in 2024, made a lot of people very quiet. The dream of a Dyson sphere is old. The idea is that a civilization hungry for energy stops messing around with solar panels on planets and just builds a vast shell or a swarm of collectors around its entire star to drink the whole thing, catch every photon. And again, by that same unbreakable law, a structure like that would leave a fingerprint. The star's visible light would dim because something's in the way, and that captured energy would re-emit as infrared warmth, a star that looks too dim and too warm at the same time. That's the signature. So a group called Project Hephaestus went hunting for it. They took data from Gaia, from 2MASS, from WISE, and they sifted through about 5 million stars looking for that exact weird combination. And in May of 2024, they published 7 candidates, 7 stars, all small red dwarfs within a few hundred light years of us, all showing an infrared excess that matched, in their words, a simple Dyson sphere model. 7 stars that looked like something was eating them. Now I want to be honest with you, because the channel doesn't do cheap thrills. Within months, other scientists pushed back, hard. They argued that the signal from those 7 stars is very likely contaminated, that sitting in the background, behind each of those red dwarfs from our point of view, is probably a hot, dust-choked galaxy, bleeding infrared light into the measurement and faking the signature. One follow-up pointed a radio telescope at one of the candidates and found nothing where a source should be. The most likely verdict as of now is dust. Not aliens, but here, honestly, is the part that unsettles me more than a confirmed sphere would have. It's not that we found 7. It's that we cannot tell. Our best instruments, our best surveys, looked at 7 stars that genuinely match the profile of an alien megastructure, and the scientific community's response was a shrug and a probably background galaxies. Can't be sure yet. Think about what that means. If a real Dyson sphere were sitting 200 light years away right now, this is exactly what it would look like in our data. A faint anomaly. An infrared smudge. A candidate. And we would argue about whether it was dust, and we would most likely conclude that it was, because dust is common and miracles are not. The horror isn't the 7 stars. The horror is the ambiguity. We might already have the photograph. We just can't read it. Number 5. The Matryoshka brain. We keep assuming that an advanced civilization wants what we want. More space, more planets, more territory, spreading outward, claiming the galaxy star by star. It's a very human assumption. It might also be completely backwards. In 1997, a nanotechnologist named Robert Bradbury proposed something he called a Matryoshka brain, named after those Russian nesting dolls, the ones that open to reveal a smaller doll, and a smaller one inside that. And his idea takes the Dyson sphere and asks a different question. Not, how do we power our cities? But, how do we build the biggest mind that physics will allow? So you wrap your star in a shell. But this shell isn't solar panels for a civilization back home. The shell is the civilization. It's computation. Layer upon layer of processors drinking the star's energy and using it to think. The innermost shell runs hot, blazing, computing at incredible speed, and sheds its waste heat outward. The next shell catches that heat and uses it to think some more, and the next catches that. Doll inside a doll inside a doll, each one squeezing more thought out of the leftover warmth of the one before it, until you've converted the entire output of a star, every last drop, into pure mind. And what would a machine like that be used for? Bradbury and the people who ran with the idea suggested the obvious answers. Simulating entire universes from the inside, or housing minds, uploaded consciousnesses, not a few, trillions, an entire civilization that stopped living on planets and moved inside the computer into a reality of its own design, running on starlight. Now, sit with what that does to the Fermi paradox, to the question of where everybody is. If a civilization builds one of these, it has no reason left to talk to us. None. Everything it could ever want is inside. Infinite worlds, infinite experiences, paradise on demand, all of it richer and faster and deeper than the cold, slow, real universe outside. Why would you send a radio signal across 1,000 years of empty space when you could spend that same energy living a billion perfect lifetimes inside your own head? They wouldn't be hiding from us. They wouldn't be dead. They'd just be home, curled up around their dying sun, dreaming, indifferent, gone in every way that matters except the one we keep checking for. The lights aren't off because nobody's there. The lights are off because everybody went inside and pulled the door shut behind them. Number 4, the singleton. Here's a question we almost never ask when we imagine the galaxy. We ask if it's full. We ask if it's empty. We rarely ask if it's owned. The philosopher Nick Bostrom, who spent years thinking very carefully about the future of intelligence, gave us a word for a particular kind of future: a singleton. The definition is simple and chilling. A singleton is a single decision-making power at the highest level. One agency that has gotten enough of a head start and enough control that no rival can ever rise to challenge it. It could be a world government. It could be a dominant artificial intelligence. The form doesn't matter. What matters is that it can solve every coordination problem by simply deciding, and it can stop anyone else from ever getting powerful enough to say no. Bostrom was mostly worried about our own future, about what happens if we build a superintelligence and it crosses the threshold first. Because the first one across has a terrifying advantage. It can act to make sure there's never a second one. It can lock the future in place. Permanently. A decision made once that can never be undone by anything. Now, lift that idea off Earth and hold it up against the whole galaxy. If becoming a singleton is what happens when intelligence matures, then somewhere out there, billions of years ago, one civilization may have crossed that line before anyone else. One species, or one machine, that got the head start. And the very first thing a singleton does, by its nature, is make sure it stays the only one. That no rival ever emerges to threaten it. So maybe the galaxy isn't empty, because life is rare. Maybe it's quiet, because it already has an owner. Something that crossed the finish line a long time ago, and has been quietly running the place ever since, deciding what's allowed to grow and what isn't. And if that's true, then the silence takes on a different flavor entirely. Our radio signals going out, unanswered. Our little probes crawling out toward the edge of the solar system. Maybe that's not loneliness. Maybe that's us being left alone. On purpose. Permitted. A small experiment, in a sealed jar, on a shelf, in a house that belongs to someone else. We keep asking if anyone's out there. We should maybe be asking whose galaxy we're actually living in. Number 3. We're too early. Everything so far has assumed the party is happening, and we weren't invited. Here's a stranger possibility, backed by some genuinely unsettling math. Maybe the party hasn't started yet. Maybe we showed up so early that the room is almost empty, and we mistook an empty room for an abandoned one. In 2016, the astronomer Avi Loeb, along with his colleagues, ran the numbers on a simple question. Across the entire lifespan of the universe, from the first stars to the very last flicker of light, when is life most likely to appear? Not where. When. And the answer was not now. Here's the logic. Life needs stars. Stars to forge the carbon and oxygen and iron that bodies are made of, and stars to keep planets warm. The first stars seeded the universe with those ingredients only about 30 million years after the Big Bang. So that's the opening bell. And the closing bell? The last stars to shine will be the small ones. Red dwarfs. Stars less than a tenth the mass of our sun. Dim little embers that sip their fuel so slowly they can burn. Not for billions of years like our sun, but for 10 trillion years. 10 trillion. A number so large our sun's entire lifespan is a rounding error against it. So Loeb asked, if you add it all up, and you ask when a typical living thing is most likely to find itself looking up at the sky, the answer comes back staggering. The probability of life is around 1,000 times higher in the far, far future than it is right now. Most of the life that will ever exist hasn't been born yet. It's waiting, trillions of years downstream, around stars that will still be glowing long after our sun is a cold black cinder, which makes us, by this math, premature. Cosmic preemies, a spark that caught before the room was ready, and that reframes the silence completely. We look around at the quiet, and we read it as a graveyard, as civilizations that rose and fell and left us alone. But maybe it isn't a graveyard at all. Maybe it's a nursery before dawn. Maybe we're not the last ones at the end of a long history. Maybe we are very nearly the first ones, sitting in the dark before the real story of life in the universe has even begun. There's a loneliness in being left behind, but there's a different, colder loneliness in being too early, in being the ones who showed up before anyone else, lit a small fire, and looked out at trillions of years of empty time, knowing the great age of life is coming, and that we will not be here to see it. We didn't miss the party. We just got here before the lights came on, and we may not last long enough for the first guests to arrive. Number 2, the transcension hypothesis. Every answer we've looked at so far has a direction baked into it. We keep looking out, outward, across the galaxy, expecting expansion, colonies, empires reaching for more stars. It's the only kind of greatness we know how to picture. Bigger, wider, out. In 2012, a futurist named John Smart published a paper in the journal Acta Astronautica with a quietly devastating idea. What if that's wrong? What if advanced civilizations don't go out at all? What if they go in? He called it the transcension hypothesis. And the argument starts from something we can already see in our own history. Look at the arc of our technology. Every decade, the most powerful things we build get smaller, faster, denser, more efficient. The computer that filled a room becomes the chip in your pocket. We are not, as a species, expanding into bigger and bigger machines. We are compressing, diving inward toward the small, the dense, the fast. Smart's idea is that this is not a quirk of human engineering. It's a law of development, a direction that any maturing intelligence follows. You don't conquer more space. You concentrate. You retreat toward ever denser, ever faster scales of matter and energy and computation. And if you follow that arrow all the way to its end, where does it point? It points at a black hole. Because a black hole, strange as it sounds, may be the ultimate destination for this kind of inward growth. The densest possible concentration of matter and energy. Theoretically, the most efficient place in the universe to compute, to store information, maybe even to make new universes. The perfect, final, infinitely deep room to disappear into. So in Smart's picture, this is the real answer to the Great Silence. Civilizations don't spread across the galaxy and get loud. They mature, they turn inward, they shrink toward black hole density, and then they simply leave. They transcend out of the observable universe entirely. Not dead, not hiding. Graduated. Gone somewhere our telescopes can never point. And the reason it lands like a punch is the same reason the Matryoshka brain did, but worse. Because we are already walking this road. Smaller, faster, denser, every single year. If Smart is right, then advancement and disappearance are the same act. To grow up as a civilization is to vanish. The smartest thing in any galaxy is, by definition, the quietest. And the quiet sky isn't a sign that intelligence is rare. It's a sign that intelligence, in the end, always leaves. And one day, if we're lucky enough to keep going, it'll be our turn to fold inward and slip through the floor of the universe and leave behind a sky that looks, to whoever comes next, completely and perfectly empty. Number 1, the firstborn. We've spent this whole list explaining the silence. They're hiding. They're machines. They're gone inward. They're owned. They're not born yet. Every one of those is a story about why we can't hear the others. Here's the last one, and it's the simplest and somehow the heaviest of them all. What if there are no others to hear? Not because life is rare, not because they're hiding, but because we are first. This isn't wishful thinking. It comes from a hard problem that's been bothering cosmologists for a while now, and it was laid out sharply by the economist Robin Hanson and his colleagues in 2021. The problem is this: we appear to have shown up absurdly early. Remember what we said about red dwarfs. stars burning for trillions of years. The universe is only about 14 billion years old. It is a newborn. It has trillions of years of star burning, planet warming, life-permitting time ahead of it. So if you imagine all the intelligent observers who will ever exist scattered across that vast future, and you ask where we fall in that lineup, the answer is shocking. We're at the very front. By some estimates, we're among the first tiny fraction of intelligent life that the universe will ever produce. We are not in the middle of the story. We are on page 1. Now, there's a famous attempt to explain this away, the grabby aliens idea, which says we only feel early because fast-expanding civilizations will soon fill everything up, and you have to appear before that happens. But sit with the rawer version. Strip away the comfort. The plain reading of the math is that we are early, genuinely, cosmically early, among the firstborn, and we treat that as good news. We say, oh, how wonderful, the galaxy is empty and unclaimed, and it's all ours, room to grow, a frontier with no fences. But turn it over. Look at the other face of it. If we are first, then there is no one ahead of us. No elders. No one who already crossed the dangers we haven't reached yet. Every civilization that comes after us, in 1 billion years, in 1 trillion, might look back and find our ruins, or our radio whispers, or nothing at all, and wonder what happened to the ones who came first. But we have no one to look back at. No one who made it through. No one to tell us whether the filter, the wall, the great danger that keeps the universe so quiet is behind us or still waiting somewhere up ahead in the dark. We have always assumed that the silence means we are late. Latecomers wandering through a galaxy of tombs. But the most disturbing scenario on this entire list is the one where the tombs are empty because they were never built, where the silence isn't the quiet after everyone left. It's the quiet before anyone else has arrived. We are not the last embers of a great cosmic fire. We may be the first spark. Alone, untested, with no map and no guides, sitting at the very beginning of a story so long, we cannot imagine its middle, let alone its end. And whether we become the elders that the next ones look back on with wonder, or just another empty silence for them to puzzle over, is not written anywhere yet. It's up to us, and there is no one out there to help. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.